Okay, welcome back to EC concept once again. Now we are going to look about DSS, design of steel structures short note series. Under that, compression member. Okay, we are going to see now compression member. Okay, compression member. So what is a compression member? It is a member which takes only the axial force, okay, or compressive force. Okay, here the first one is we are going to see first concept is a slenderness ratio. Slenderness ratio that you have to keep in your mind. Okay, that is lambda. So what is the thing first? A compression member, a compression member subjected to a compression member subjected to compressive load, compressive loads resulting from dead load plus live load combination. Dead load plus live load combination, that is lambda, which is equal to 180. Okay, next one. A compression member subjected to compressive loads, okay, resulting from this is the dead load live load combination. This is due to wind load or earthquake load, okay, or earthquake load. Lambda, which is equal to 250. Next one, for compression flange, for compression flange of beam, for compression flange of beam is equal to 300. Okay, next one is for lacing member. For lacing member, this we will see. Okay, for lacing member 145. This is important examination question. Okay, this is all about slenderness ratio. Next one, second one is we are going to see effective length. Okay, this is important concept. Effective length. Effective length, that is L effective. Okay, L effective. We are having some of the conditions. First one is support conditions. Support conditions. Theoretical. Theoretical. Recommended. Theoretical. Recommended. Okay. For theoretical, okay, okay, here recommended means code recommendation. Okay, code as per IS 456 2000 and IS 800 2007. Okay, Now, the first column is both end pinned. For both end pinned, L effective, which is equal to 1.0 L. Okay, and recommended also L effective, which is equal to 1.0 L. This is the first one. Second one is one end is fixed, other end is hinged. For this case, L effective, which is equal to 0.7 L. But L effective recommended as per code 0.8 L. Okay, this is all about the second one. Next one is both end is fixed. L effective, which is equal to 0.5 L. This one, L effective, which is equal to 0.65 L. Okay, and next one is L effective support condition. Theoretical or recommended. Theoretical or recommended. Okay. So both end fixed we having seen. Oh, one end is fixed, other end is free. L effective, which is equal to 2L. Here also L effective, which is equal to 2L. Okay. This is a third case. Sorry, fourth case. Now the fifth case is one end is fixed, other end is restrained against rotation but not restrained against translation. This one is restrained against rotation. Why rotation? Because slope at this point is 0, but not restrained against translation. See this one? This is not restrained against translation. Okay. Therefore, this case L effective is equal to 1.2 L. Okay. And L recommended L effective is equal to 1.2 L. Okay. 1.2 L. So actually, this is not 1.2 L. This is 1. Here. Next one is, okay, one end is hinged, other end is something like that. Restrained against rotation, but not restrained against the translation. The same thing here. Okay, restrained against rotation, but not restrained against translation. Restrained against rotation, but not restrained against translation. Not restrained against translation. So for this case, L effective. For this case, L effective is equal to 2 L, and this also L effective is equal to 2L. Recommended also same. Okay, so these are the some of the formulas or values you have to keep in your mind. Total 6. In this 6 case, you have to keep in your mind so that you can able to attend a question. Okay, this is all about the second concept. Okay, that is a slenderness ratio. Okay, now next we are going to see the design of built-up column. Third one is we are going to see design of built-up column. Design of built-up column. There are two built-up columns that we are having. Okay, first one is that is capital A, lacing built-up column. B, batten built-up column. Lacing built-up column and batten built-up column. So these two things you have to keep in your mind. So now we are going to say first one, lacing built-up column. So here only we are going to see the design procedure, what is required for our examination. Okay, A, design of lacing system. Design of lacing column. Design of lacing column. You know, the lacing column system, it looks something like that. So this is the column, the lacing column. Okay, the lacing column. Okay, okay. Now, in the lacing system, top and bottom is connected by a batten. So this is the batten. Okay, one batten always you have to use at the top and bottom. These are set by code. Okay, top and bottom always you have to use one batten. Okay, so this is, we can call it as tie plate or batten plate or batten plate. Okay, and this is, we are saying base plate. This is, we are saying base plate. Okay, now you know the connection is, it starts from here. Okay, something like that. Then connection end, this one, and this is the another one, batten. Sorry, this is the lacing system. It is connected, connected, connected. Okay, this is the lacing system, and this lacing system makes an angle. This is the lacing axis, longitudinal axis, longitudinal axis, longitudinal axis of the component. Okay, this lacing system makes an angle of theta with respect to vertical. So this also theta, theta with respect to vertical. Okay, this is the diagrammatic representation. Now see, You are going to write this important point. Okay. First one. Point number one. Lacing is a system of lacing is a system of connecting elements, system of connecting elements of a built up column. Lacing is a system of connecting elements of a built up column. Okay, so that means suppose this is the one column, this is another column, that is column component. If you want to make a built up column, then connect these two column component by using the lacings. Understood? That's the point says. Okay. Next one is lacing member makes the component of column makes the components of column act as a single unit. Act as a single unit. That means this is the lacing member. This lacing member makes the column component. So these two are the column components. Okay. Column components. These two are column components. The lacing member makes these two column components as a single unit. Okay. It's a single unit. Okay, that's a point. Now, second point, lacing members are designed as truss element. That is, they are subjected to tension and compression only. Tension and compression. Tension and compression only. Now, bending moment is 0 in lacing member. So this point is important. The lacing members are designed as a stress element so that the truss element we know that subjected to only tension or compression force, right? And there is no bending moment. So that's why the lacing members are subjected to either tension or compression, but there is no bending moment. Okay. Third point that we are going to see, if lacing members are used, if lacing members are used, then effective length of column is increased by 5% in our calculation. We have to increase 5% in our calculation. Okay. Why? To take care of longitudinal shear force and shear deformation. To take care of longitudinal shear force and shear deformations effects produced by the truss on the column. On the column. Okay. Why we are increasing 5%? In order to take care of longitudinal shear force and shear deformations produced by the truss, that is a lacing member, produced by the truss on the column. So not a lacing member, the truss which is supported by the column. Okay, that one. Okay, now next point, by increasing, not next point, the continuation of this point we can write. Okay, now by increasing effective length, by increasing effective length of the column by 5%, design compressive stress decreases. FCD is a design compressive stress decreases. So AG provided will be more. This additional gross cross sectional area of the column, cross section area of the column will take care of additional load exerted by lacing system on the column. Okay, by increasing the effective length, once you increase the effective length, automatically the design compressive stress reduces. If the design compressive stress reduces, then the cross section area will be increased. We are just increase the cross section area. Once we increase the cross section area, that will take care of the additional load which is exerted by the lacing system. Okay, now next point, these are as per code values. Okay, maximum slenderness ratio for lacing member, slenderness ratio for lacing member is equal to 145. Is equal to 145. Next point, angle of lacing with respect to angle of lacing with respect to vertical is theta should not less than 40 degree and theta should not greater than 70 degree. So this point you have to keep in your mind. Theta should not less than 40 degree, should not greater than 40 degree. So meaning the theta varies from 40 to 70. Okay. The next one is, next point that we are going to see, to prevent buckling of the column component, between lacing connection, the following conditions must be satisfied. That is C divided by R minimum, should not greater than 50. The meaning is this one. This is the center to center distance between the lacing member. Okay, so this is the spacing of lacing system. C. In order to avoid the local buckling between these two lacing member on the column, that is a local buckling of this portion of column component. Okay, we have to, that is column component, this condition shall be satisfied. So this is the component. Okay, component, and should not greater than 0.7 lambda into whole column, the whole column, cylindrical ratio of whole column. Okay, where C is equal to spacing of lacings. Okay, so this is the point. Point is no, if the above condition, if the above condition is not satisfied, then first point, what we can do, increase the value of theta up to 70 degree. Second point, provide double lacing. Provide double lacing so that C value will be less. Provide double lacing so that C value will be less. Okay. Next important point is dimensions of lacing. Dimensions of lacings. Dimensions of lacing, that is the important point. Okay. In that, first one we are going to see length of lacing bar. Length of lacing bar. Length of lacing bar, that is L1. Okay. It is taken as, the distance between inner bolt or welds. Inner bolt or welds. Okay. As shown in figure. That means this one. Listen. The inner bolt. So L1 means this one. This is the L1. Okay. Distance between this bolt and this bolt. This distance we can say L1. Length of the lacing bar. Okay. Now we can move further. The length of the lacing bar. Okay. Next one, second one is effective length. Effective length of lacing. Effective length of lacing bar, that is L effective. Okay. Here L effective, which is equal to L1 for single lacing. L effective is equal to L1 for single lacing with one bolt or two bolt. One bolt or two bolt. Now, L effective is equal to 0.7 L1 for double lacing. For double lacing. Similarly, L effect is equal to 0.7 L1 for L1 means length of the lacing bar for welded lacing. For welded lacing. So these are the points. Third one is this is the effective length. Third one is minimum width of lacing bar. Minimum width of lacing bar. Minimum width of lacing bar, that is D minimum, should not less than 3 times the diameter of bar. Okay, this is not diameter of bar, diameter of bolt. That is nominal diameter of bolt. Nominal diameter of bolt. Fourth one, minimum thickness of lacing, that is T minimum, should not less than L effective by 40 for single lacing. For single lacing should not less than L effective divided by 16 for double lacing. For double lacing. Fifth one, this is a minimum thickness. Okay, fifth one, slenderness ratio. Slenderness ratio, that is lambda, which is equal to L effective divided by R minimum. L effective divided by R minimum, that should not greater than 145. We already seen this, right? Okay, so this is all about the lacing bar, dimensions of lacing. Okay, next point, that is the main point. Lacing system on opposite side, on opposite of the column, opposite of the main component should be mirror image of each other. Should be mirror image of each other. The lacing system, that means this is a mirror image of each system. So this is the front side. If you take, this is the lacing system and the same mirror image. Okay, this is the column, right? This is the front side, this is the back side, for example. You used the lacing system for front side. In the back side also, the mirror image of this will be on the back side. Okay, so that's says the mirror image. Okay, the mirror image of each other. Now, next point, the lacing system should not vary throughout, the length of the column. That is width, thickness, comma, theta of lacing member. Theta of lacing member shall be same throughout, the length of the column. Okay, so that analysis will be simple, and transfer of the load transfer of the load from the truss transfer of the load from the truss to the column is symmetrical. What they are saying, see this one, in this lacing system, the spacing of lacing system, the width of the lacing system, thickness of the lacing system, this angle, everything shall be same throughout the length of the column, so that the analysis will be simple, and the column, that is load transfer mechanism, also symmetrical. Okay, the load transfer also symmetrical. For that reason, we are keeping the width of the lacing system, thickness of the lacing system, this theta of the lacing system, the spacing of the lacing system, everything shall be keep it same or uniform throughout the length. Okay, length of the column common. So this is the point. Now next important point is, at the end of the lacing system, at the end of lacing system, at the top and bottom, tie plates are used. Tie plates or batten plates are provided. At the top and bottom, tie plates or batten plates are used. Okay, see this one. At the end of the column lacing system, this is the top end, this is the bottom end. Okay, in the bottom end and the top end, you have to use the tie plate or batten plate. So this is also called tie plate or batten plate. Tie plate or batten plate, we have to use it. Okay, that is all about the things. Okay, now forces on lacing system. Okay, forces on lacing system. One, lacing system is designed to resist a transfer of shear force V is equal to 2.5% of column load. Transfer of 2.5% of column load. Okay, lacing system is designed to resist a transfer of shear force V is equal to 2.5% of column load. Why? To take care of axial load and moments arising due to accidental lateral loads. Okay, now second point is force shared by, that is force on lacing bar, which is equal to V divided by N sin theta. It can be either tension or compression. either tension or compression. Either tension or compression. Meaning of this is, suppose this lacing member is subject to tension, then automatically this is subjected to compression, vice versa. If it is subjected to compression, then this is subjected to tension. Understood, right? So that is the meaning of this. Okay. Now, where n is the number of parallel planes, then is the number of parallel planes of lacing. Okay, so n is equal to 1 for single lacing, n is equal to 4 for double lacing. Okay, n is equal to 4 for double lacing. Now, next one is number of bolt calculation. Number of bolt calculation at the joint, which is n is equal to total vertical force, the whole divided by rivet value. So which is equal to 2f cos theta divided by rivet value. So that is n. Understood? So this is all about the lacing system. Okay. And one more point we can write, that is, as far as possible, horizontal cross members between double lacing system are avoided. Horizontal cross member between double lacing system are avoided. Okay, so meaning, so for example, this is the member column component. Here we used lacing system. Here we use the lacing system. Suppose this is the lacing system. In between that, you don't use any horizontal member. If you use a batten or something like that, then this joint becomes as a indeterminate joint. Analysis is very difficult. Indeterminate joint. So this is very difficult to analyze. So that's why, as far as possible, horizontal cross member between the double lacing system are avoided. That is shall be avoided. System shall be avoided. If you use it, then the system becomes as a indeterminate. So analysis is critical. That is a difficult. That is the reason the code says don't use it. Okay. Now the next one is B. Batten system. Batten system. Batten system of column. So first we having seen the lacing system. Now we are going to see the batten. Okay. Design of batten. See here also. First let me see the diagram. This is the base plate of a column. Base plate. So this is your column component. Okay. Okay. Now, this is the batten. Batten is a straight horizontal member. Lacing is an inclined member. That is a difference. Okay. This is the batten. Okay. Batten. Now, C is the center to center distance between the batten. Center to center distance between the batten. Okay. Now, if you want, we can take it as one more. Okay. That's enough. Okay. Now, X is the clear spacing between the column component. So, from this to this distance is the clear spacing between the column. X. X is the clear spacing between the column. Okay. Now, G is the gauge line. So, this is the gauge line means where the rivet or bolt, first bolt, okay. From this first bolt line, and this is the first bolt line. And this distance is G. G is the gauge distance. Now, for a column, there was a component that is CYY. The centroid of column, this is CYY, centroid of the column. Okay. Now, distance between this, the centroid of the column component, and this centroid of the column component, that is alpha. Centroid of the column component. This is the centroid of the column. Centroid of column. Here also centroid of column. Okay. Now, X is S1. This is the S1. S1 is the distance between centroid of first bolt, inner bolt. Okay. Now we are going to write one by one some of the point. First one, where we are going to write X is equal to clear spacing between column component. First one. Second one is G. G is equal to gauge distance, where bolt line is provided. Okay. G is the gauge distance where the bolt line is provided. Okay. So this is the first bolt line. This is the first bolt line. So in between the center to center distance between the first bolt line. Okay. Distance between the first bolt line. Now CYY, it is the centroidal distance of channel from back of the channel. Alpha, distance between, see the diagram, distance between centroid of column component, which is equal to x plus 2 times the cyy. S1, which is equal to distance between innermost. See, alpha is the distance between this blue line and this blue line, right? Understood, right? That is x is the clear spacing. 2 times this is cy, this also cy. That's why. S1 is the distance between innermost bolt line is equal to x plus 2g, right? This is the innermost bolt line. X plus 2g is S1. So this is the S1. Now what is the S? S means suppose here we used only one bolt. If you use n number of bolt, then yes, you have to take S is equal to distance between center of gravity of bolt group in transverse direction. In transverse direction. So group in transverse direction. Okay. So if we use n number of bolt, then center of gravity is our bolt line. The distance between the center of gravity of bolt line is S. If it is only one bolt, then S1 we have to take it as. Okay. Now we are going to see important points as we having seen in the lacing system. Okay. First point, battening is also a method of connecting elements of built-up column. Method of connecting built-up column, like a lacing. Okay. Now, battens are designed as framed members, that is, battens are subjected to shear force and bending moment. Shear force and bending moment. Okay. Now, next point is we are going to see minimum number of battens. Minimum number of batten is equal to 4. Minimum number of batten is equal to 4. Okay, you have to take into account. Minimum number of batten is 4. What is the meaning? So that the column is divided into a minimum of 3 bays. Minimum of 3 bays to ensure that battens behaves like a frame. So minimum 3 bays. So that's why we need at least 4 batten. So meaning this is one column component. This is another one column component. Okay. This is one pattern. This is another one pattern. This is another one pattern. Okay. 4 pattern we have to use. Okay. This is the fourth one. Fourth pattern. 4 pattern used. How many bays are there? Bay number 1. This is bay 1. This is bay 2. This is bay 3. Okay. So minimum number of pattern we have to use is 3, so that we can make a 3 base at least. Okay. Next point is under pattern. Patterns are provided. Patterns are provided. Are provided with effective length. The effective length of column effective length of column increased by 10% in our calculation. But in the lacing system, we have taken as 5%, but here 10% in our calculation. Why? To take care of to take care of to take care of longitudinal shear force and shear deformation and shear deformations effect. Shear deformations effect. Okay. Now, next point, to prevent buckling of column components, between the batten, the following conditions must be satisfied. The following conditions must be satisfied. That is C divided by R minimum of component should not greater than 50 and should not greater than 0.7 times the lambda for a whole column. Lambda for whole column, same as the lacing system. Okay. Next point also same. Provide mirror image of pattern on both sides. Provide the pattern on opposite side of the column such that they are mirror image such that mirror image of each other, Okay. Why? To make the analysis simple. To make analysis simple, we are taking on opposite side of the column as a mirror image. Okay, mirror image of pattern, you have to use it on opposite side of the column. Okay, now next point is dimensions of column. Sorry, pattern. Dimensions of pattern. Dimensions of pattern. What is this? First one is effective depth of intermediate pattern. Effective depth of intermediate effective depth of intermediate pattern. Okay, that is d inter. So d intermediate should not less than 3 by 4 of alpha, should not less than 2b. D end. Okay, effective depth end is equal to should not less than alpha or 2b. This is end. Okay, so I have to write only effective depth. Effective depth. First one is effective depth. This is the intermediate pattern. DINTER mean intermediate pattern. Intermediate pattern. D end pattern. D end pattern. Okay. Now, second one, minimum thickness. Minimum thickness, that is T minimum. So T minimum should not less than alpha, should not less than, sorry, T minimum should not less than S1 divided by 50. That means this is center to center distance between the inner bolt S1, right? So next point is forces on pattern. Forces on pattern. Forces on pattern that we are going to see. First one is transverse shear force. Transverse shear force on pattern, which is equal to same as lacing system 2.5% of column load. Second one is the longitudinal shear force. Longitudinal shear force. Longitudinal shear force on pattern, which is equal to VC. Actually, this is the V. Okay. VC divided by NS. Okay. Now, third one, bending moment. Bending moment on pattern. Bending moment on pattern, which is equal to VC divided by 2N, where V is equal to transverse shear. Transverse shear. C is equal to center to center distance between pattern. S is equal to center to center distance between centroid of bolt group. Okay, already explained this, yes, right? Or not center to center distance between the centroid of bolt group. That is yes. Okay. S is equal to this. N is equal to number of parallel planes. So this is all about batten. Okay, this much is enough. Okay, so this is the design of compressed member. You have to keep this in your mind. First slenderness ratio, effective length. Okay, then design of built-up column, lacing built-up column, batten built-up column. These all are the IS code 800-2007 descriptions. Okay, so read it 4 to 5 times. Okay, that is enough for your examination perspective. Okay.